Now that we know about speed and velocity, we can take this a step further now and we can talk about acceleration. So what is acceleration? It is the rate of change of velocity. Okay, so it's that change in speed, or it could be a change in direction. Okay, because remember, velocity is a speed within a given direction. Okay, here is our equation for today. Go ahead and add this in onto your equation chart that we've been growing. A equals v of f minus v of I divided by t. Okay, and so what do each of those letters mean? A is your acceleration. That's your rate of change of velocity. Its unit is meters per second squared. So you may want to add that in on your equation sheet, what the expected unit is. Now, v of f, this is your final velocity. So this is your ending velocity. V of I is your initial velocity. So that is your starting velocity. You have to be careful here. Read the problems very carefully so you can make sure you know which velocity goes in which location. That's a big place where students get tripped up, is they just put them in the wrong spot. Okay, and it does make a difference. Since both of these are velocities, both of them should have the same unit, and that is usually going to be meters per second. And then T stands for time. This will usually be in seconds. Okay. Even though we have this extra factor in here, there's 4 factors instead of just 3, we can still use our triangle method to help us set up our equations and know how to solve for our unknown. The VF minus VI is going to go on the top. And make sure you always think of these as being in parentheses, because you always want to subtract before you divide. Okay, so put those in parentheses on your equation sheet. Okay, A is going to go bottom left, T bottom right, and then just like the triangle has been working for us so far, it's going to continue to work for us and tell us how to do these solving for the unknowns. Okay. All right, so something that we can remember here is that a positive acceleration, so we calculate this out and we get a positive number, that means that the object is speeding up, it's gaining speed. If it's a negative number when you calculate acceleration, that means the object's slowing down. And so this is great because this gives us a way to analyze our work and sort of double check and say, is my answer what I expected? So if in the problem it's talking about gaining speed or going faster, we know that our answer should be positive. So when we get our answer, if it's not positive, we know we did something wrong and we need to go back and reassess and recalculate. Same idea if in the problem it says that something is slowing down or it's losing speed, hit the brakes, something like that, we know we should be calculating a negative number. So when we calculate it out, if we get a negative number, we probably did it right. But if we get a positive number, we know, okay, I did something wrong. We need to go back and double check. Okay? So just use that sort of information, keep that in mind, so you can analyze your work and see if you got an expected answer. Okay, here's all of your units for velocity and acceleration that we've been studying. So if you don't already have this on your equation sheet to go along with each equation, you can take a minute, pause the video, and copy this down either into your notes or onto that equation sheet as needed, and then just push play when you're ready to move forwards. Let's do some example problems using our new acceleration equation. Okay, a roller coaster starts down a hill at 10 meters per second. 3 seconds later, its speed is 32 meters per second. What is the roller coaster's acceleration? So let's break this problem down and let's see what we know and what we need to know. Okay, so we know our initial volume because it says a roller coaster starts down a hill at 10 meters per second. So it starts there. So that's our initial, that's our beginning. We have a time because then next it says 3 seconds later. So that's our time. Its speed is 32 meters per second. That's our final velocity. That's our ending point for this problem. What is the roller coaster's acceleration? Okay. So since I have two v's and I have a t and I'm trying to solve for a, I know I need my acceleration equation. I know it seems silly to say that now since this video is all about acceleration, but remember, in a few days, you're going to have something with all kinds of different problems, and your job is going to be to pick out which equation you need to use. So you need to analyze what kind of factors do you have here? Which equation do I need to use? Okay, so here's our triangle to tell us how to solve this. My a is my unknown, so I'm going to cover that up. That's what I'm solving for. And the triangle tells me v of f minus v of I divided by t is how I will solve this. Okay, thank you, triangle, for making this so much easier. And then we just plug in our numbers. Okay, so our final velocity is 32. Our starting or initial velocity is 10 meters per second. And our time is 3. So we just plug that in. Okay, now remember, be careful. If you are just plugging this into your calculator, you have to tell your calculator how to do it properly. If you just type in this, 32 minus 10 divided by 3, you're going to get the wrong answer because your calculator doesn't know how to do math correctly without you telling it. So if you're going to do this, make sure that you put the subtraction in parentheses. So parentheses 32 minus 10, close parentheses, divided by 3. Then your calculator will do the order of operations correctly for you, and then you will get the correct answer. Okay? Or you can do it step by step. So if we do it step by step, first we're going to subtract. So 32 minus 10 is 22. Since you're subtracting and the two units are the same, you keep that same unit. And then you divide by 3 seconds. So since you've got meters over seconds and divided by seconds, that means both of those seconds are on the bottom. So that becomes seconds squared. Okay, so that's your meters per second squared if you're following with those units. Okay, so 22 divided by 3 is 7.3 meters per second squared. Okay, remember, you always have to have the number and the unit. If you don't put the unit, you're not going to get total credit. Okay? All right, let's do another problem. How long will it take a car traveling at 30 meters per second to come to a stop if its acceleration is negative 3 meters per second squared? Okay, so let's analyze. Let's see what kind of information we have. Okay, we want to know our time. How long will it take? So our time is our unknown. Okay, our initial velocity is 30 meters per second because that's how fast the car is traveling. We know our final velocity is 0 meters per second because it says to come to a stop. So a complete stop means a velocity of 0, so that's our final velocity. And we know our acceleration, negative 3 meters per second squared. Okay, so here's all of our information that we know and what we need to know. So let's take a look at our triangle. T is our unknown, so let's cover that up. So the triangle says what we need to do is v of f minus v of I divided by a. Okay, so go ahead and write that out. And then just plug those numbers into the correct locations. Okay, final velocity, remember, is 0 because we're stopping. Initial velocity is 30, and our acceleration is negative 3. Okay, and again, remember, if you plug this into your calculator, you have to put that subtraction in parentheses or it will not do it correctly for you. Okay, so if we do 0 minus 30, that gives us negative 30. And we're going to divide that by negative 3 meters per second squared. Okay, and what happens is we've got meters per second divided by meters per second squared. So the meters per second cancel off and we're left with just that extra second. So we're left with seconds. And since we're looking for time, that's the unit that we want. Okay, so negative 30 divided by negative 3 equals 10 seconds. So it will take this car 10 seconds to come to a stop at the acceleration of negative 3. Okay, I have my number and I have my unit. If you don't understand how to do these problems, if you're not getting the same answers as you're working along with me, please get into contact with me. Let me know so I can help you out because up next is some independent work.